at this moment. Okay, so welcome to, this is the first regular statistics webinar. Yesterday we had our orientation webinar, which is very different. Today is a webinar on statistics. And what the plan is, in fact, let me share my desktop and then I'll go over the plan and see what's happening. So let's do that. Okay, so hopefully you can all see it. If I say something and I say I'm reading it and you can't see it, let me know, but I'm pretty sure you can. So the plan is I'll start out with any questions you might have.
You love me enough to bring me a truly?
Assume that there's questions. Feel free to ask questions and talk, but if you don't have a question, please mute yourself so that we don't have the background noise. So I'll start out with any questions you might have. And then after that, we're going to start and talk about chapter 1. Okay, so we're going to start out about chapter 1. And in particular, we're going to be looking at sampling techniques. Collecting a sample that is representative of the population is actually a gigantic challenge. To come up with a sample, you know, that works is actually a lot of work. And we're going to talk about different strategies on doing that. And these are, you know, statistical sound strategies we'll be looking at. Particularly looking at, I'll start out actually with just statistics and parameters, but that's a small thing. We'll look at random sampling, which is the best, which you can almost never do. Then we'll look at stratified sampling, which is pretty good, but unfortunately, sometimes it's hard to do. And then we'll look at cluster sampling. That's easier, but sometimes has some worse bias. Everything has issues. Then there's systematic sampling, which is great for certain situations, and other situations you can't do it. And we'll also look at convenience sampling, which is the easiest of all and is worthless. So there's no perfect solution, unfortunately. That's why I have to talk about them all. Then that's the main thing we'll do for chapter 1. Then after that, we're going to get into chapter 2. And chapter 2, I know that the name of this class is called statistics, but we'll talk about what is a statistic. And then we'll talk about a lot of different statistics that are used to take a look at data and understand it. Some of these you already know. I'm going to assume that you know what the mean is or the average is, because you learned that in like 4th grade or something. So most people know what the average is, but I'll remind you and talk about it. We'll talk about the median. Most of you probably know the median too. That's like the middle number. Standard deviation, some of you might know, especially if you're younger, because now it's standard in high schools. It wasn't when I was a kid, by the way. But now it is. It's part of the Common Core standards. We'll look at Q1 and Q3 and IQR. That's not standard. So, but I'll talk about what that is, and it's important. And also talk about the Z-score. So we'll see what that is and play around with that. I'll also look at charts, and there's a lot of different charts that you can show the data and kind of describe it. So there's a histogram, a stem and leaf plot, a box plot, and a whole lot of others. I'll do some of them. It turns out if I have a big, long list of things to do, that means you should smile. That means it's usually an easy chapter. If there's only 1 or 2 things, that means there's some really hard concepts. So the good news is there really aren't any real hard concepts in chapters 1 and 2. There's just a lot of stuff, but it's a lot of the stuff you've seen, and the stuff you haven't seen, it's really easy to explain. That's the good news. So that's the plan today. And let me ask y'all, are there any questions? And you can, and I want to remind you that if you say them out loud, that is posted on YouTube. If you post it on the chat box, it is not posted on YouTube. It's private. But again, really the only people that watch these are us. So you don't have to worry too much about it. But I do want to give you that disclaimer. But I'll be happy to answer any questions. Again, we're new to this class. Someone already asked a question by email, so I figured I should answer it also here. And that is, they noticed that the chapter 1 and 2 assignments, those aren't due until Tuesday. I did that on purpose. It has to do with the fact that New Year's happened on the weekend, which means we couldn't start until Wednesday. So I figured I should give you an extra couple days to do the work because I like to give you basically a week to do the work instead of only 5 days. So just let you know that those really are due on Tuesday. Some of the other stuff is due earlier because I figure you should be working a little bit every day. But the last stuff is due on Tuesday. You're always welcome to finish it early. So, and by the way, I probably should have just told the person put on the Q&A form, but those are the questions that are good for Q&A form. Are there any questions about the class, about anything about statistics? Okay, I'm not seeing anything, but if you do post a question or say a question, I'll always be happy to answer. Remember, one of the main purposes of having a webinar instead of me just giving another 1 hour video that I've got some others on is so that we can have conversations and you can ask questions and I can answer them on the spot because that has some benefits to it. So I always like to give the live webinars. Okay, I was the first basically. Now everyone does Zoom, but I was doing this many, many, many years ago, like 20. So anyhow, what I want to do is I want to go to our main. I always like to bring in relevant stuff. The thing I like best about this class is I can put relevance into this class. Okay, there's no problem. I can always pull up, and I'm going to pull up, especially since, be careful, I ask you a question and you answer, and now I'm going to use it. A lot of you are from Tahoe. So one of our main newspapers, or I guess you don't call them newspapers, web news sites, I guess, is the Tahoe Daily Tribune. And I want to look at something. I'm going to scroll down a bunch. And they have a recent poll. And they have this pretty much every week. And the poll is, what was the worst part of the deep December storm? So if you're not from Tahoe, we had a record amount of snow in terms of recorded history. The last 51 years of recorded history, we had the most snow that we've had in 51 years, which is interesting. So, and the possibilities are getting caught in a traffic jam, shoveling and snow removal. It canceled our holiday plans. I like this one. Family had to stay longer than expected, and I don't want that to happen. And NA, it was all amazing because we love snow so much. All right, so what I'm going to do is I'm going to mention one thing first. Notice that this question, the answer to the question are words. Okay, if you look at the possibilities, they're all words. That is called a qualitative variable. So I'm going to post that because I'm here. I'm going to post that in the chat box so that you can all see it. So that's called qualitative. So that means that the answers are words. And you'll see that in a second. So that's in the chat box. So qualitative means the answers are words. Okay, this is one of those cases where you don't have a choice. There's no way you can kind of massage this and make it numbers. Okay, it just wouldn't work very well. I mean, you could change the question, but if this is kind of what you wanted to ask, you really can't make it work numbers. Numbers are better when we're talking about doing statistics and calculations, and hopefully that's obvious. It's a lot easier to calculate the numbers than to calculate words. But you can do some stuff with word calculations, which we will later in the class. If the answers are numbers, then it is quantitative. So let me type that out. And I know it takes a moment for you to see it. So quantitative means answers are numbers. Okay, very important. So it's two different kinds of surveys. If you can do quantitative, do quantitative. Okay, but sometimes you can't. Okay, there's two main kinds of quantitative. Okay, and I'm going to say this one and not type it out because we're going to have whole chapters on these. There's what's called the discrete variable, and that means that you can list all the possible answers. Okay, so for example, if I asked you how many siblings are in your family, all right, then you could list all the possible answers that someone could say, right? Okay, at least one because there's you. Could be two, could be three. Okay, could be four, could be five. Okay, it can't be a million, by the way. You can't have a million siblings in your family. not real siblings. Can you have 4.5? The answer is yes, my family. So modern families can have 4.5. I have a step sibling, Lara, and then there's 4 of us biological, full siblings. So you can't have half, but you can't have 4 1/3, by the way. That's not biologically possible, by the way. But you can list all the possibilities in terms of number of siblings, and that makes it discrete. If every real number is possible, then it's continuous. And that would be what you say, what is your exact weight? So I weigh 172.35721 ... pounds. Okay, so notice that you can't list all the possibilities that someone could weigh. And that is continuous. Okay, so that's just some vocabulary. Today, this is like vocabulary day. Chapter 1 is all vocabulary. Chapter 2, you'll get to see math, but chapter 1 is only vocabulary. So again, I'm saying it kind of quickly, but again, you can always go back to the book, read the book, and you should. You can watch more videos and see the vocabulary again. So there's a lot of ways of getting this vocabulary if I say it too fast for y'all. All right, so here we have a qualitative survey question. And let's answer this question. I want you to put in the chat box what your answer is be, and I'm gonna answer it to the most popular answer. See what our class wants. So put in the chat box the answer. It'll be interesting. I asked this in my face-to-face stats yesterday, and let's see what see what we get. Give it another 5 seconds or so. All right, that was in Minnesota. All right. Family had to stay longer than expected. I won't say who you are, by the way. All right, more people said get caught in a traffic jam. So I'm going to choose that one. Okay, that seemed to be the biggest issue. Okay. It was amazing, by the way. I love snow. But so I'm going to vote. And here's the answer. Oh, look at this. So, by the way, yesterday the answer, more people did not say it was amazing. So the total voters were 283. And by the way, I'm going to assume that voters in this are Tahoe people. I know that's not a perfect assumption, but just to make life easier for this class right now, we're just going to make that assumption. Could you ask everyone in Tahoe this question in the Tahoe area? What do you think? What if I told you that was a requirement for this class? You had to go and do a survey and you had to ask everyone in the whole Tahoe area. What would happen? Yeah, you'd all drop the class, I think, right? Or cheat, one or the other. And I wouldn't do that, by the way. The point is you can't, okay? Even if you tried, you couldn't. But even if if everyone would answer your question, it would take years to ask everyone. It's really not, it's not doable. And that's true in most cases. Anytime you want to find out something about the population, the bad news is for almost every situation, you can't. Okay. So what you do to address the issue of the fact that you can't ask everyone because you just don't have the time or the ability is you take a sample. And that's what the Tahoe Daily Tribune did. They took a sample. Okay, we were one of them actually. And their sample was of size 283. Today is not the day I'm going to spend time talking about how big a sample size you need to have a big enough sample size. We'll get there a few weeks from now, about 5 weeks from now, but not today. So just trust me, we will get there. But they had a sample size 283, and if you're from Tahoe, you know that's not everyone. Okay, we do have permanent residents. We're probably have around 50,000 people in the Tahoe Basin, something like that. Might be 40,000. So I think it's 24 in South Tahoe. So we're not even close. So now the question is, do you trust these results? Do you trust that It Was Amazing is the most popular of all Tahoe residents? Or do you not trust this survey? Any thoughts? Okay, so we got one saying they would trust it. One not trust, another not trust. Okay, so we're mixed. Okay, let's take a look at this. Think about this. Okay, sample size too small. I'm not gonna prove this or anything, but I will tell you that the sample size actually isn't that small. There's other issues though. Okay, but again, it's gonna be some weeks about sample. Good. No trust, sample is biased, and that's what we want to look at. Is this a biased sample, or is this a sample that is representative of the population of Tahoe? Okay, and what you look at is you say, well, what was a survey technique? And the survey technique is they posted online, and anyone who felt like it answered the question. Does that make sense? Okay, probably not too much lying. There's that's sometimes an issue. My guess is lying isn't a big issue for this survey, but a bigger issue is, what about the people who feel like answering something like this and read the Tribune online? Are they representative of the population in terms of what they think the worst part of the deep December storm is? Any questions on that idea? So the first thing is that they did nothing to ensure that it was representative. Okay, they did nothing. So now comes the hard part. Let's suppose that you had a budget. Okay, in the real world, you typically have a budget to do something like that if you're doing a scientific study. And you need to get, let's say, a representative sample of 283, since we got that many people here, that voted, of 283 Tahoe residents. And you had a budget to do that. Let's say, you were given a few $1,000s to make it happen. How would you do that to make it as representative as possible? Any thoughts on what you might do other than just post it online? You got some money to actually spend to make it happen. Any thoughts? Okay, advertise, market, make it public, which is basically what this is. This is an advertisement. This is an advertisement. So advertisement's got the same issue as what this has, just let you know. Stand in front of a store, that could help up to a point. Multiple platforms, that helps a little bit. Okay, so let me talk about actually the right way of doing things. No offense, by the way. I don't expect you all to know statistics walking into this class. What I expect you, though, is walking out of this class, and of course, walking is figuratively as an online class. I guess logging out of this class for the last day on the final. What I do expect you by then, I expect you to really understand techniques to help prevent bias. So let me give you one possibility. Okay, let's suppose that you actually had access, okay, maybe via the police department. That's who has access, by the way. And you were allowed to use it even though you're not allowed to publicly state things, but you did have access to the list of all residents. So one way of doing a survey, remember you got some money, is you take that list of all residents. Then what you do is you give each of the residents a number. Okay, maybe alphabetically, the first one is 1, the next is 2, et cetera, et cetera. And then you randomly select 283 of those residents. Any questions on that idea? How do you randomly select 283? The answer is nowadays it's really easy. Any thoughts? Census roster. Well, we already have the roster. We have the roster that's alphabeticalized. You gave everyone a number. Yeah, make a computer do it. Okay. Make it. In fact, I challenge you. You can do this right now. Get your smartphone out and say, give me a random number from 1 to 1,000. And it will. It will. It's awesome. When I first was teaching this class, that thing called smartphone didn't exist. No one knew what those were. Yeah, Excel will do it. Your smartphone will do it. There are lots of ways to get random numbers. I programmed something that does it in the calculator that I made. That does it. So it's really easy to get a computer to generate 283 random numbers out of the whole long list. Okay, so that's the next step. The next step, and again, this is where it now comes where you have to use your money. The next step is to go grab those 283 people, pay them money to answer so that they do. Most people will answer if they get paid money. Do y'all agree? If someone gave you $10 to answer this question, would you answer it? Okay, my guess is everyone would say yes. I actually had this happen once. I got paid $100 to answer a survey. It was awesome. I was smiling so much. So again, if you're giving money, you could do that. Okay. That is called random sampling. Got it? So this is called random sampling. Random sampling, there's a lot of issues. One is getting a list of all the people is usually against the law. Okay, that's why I said only the police department has that list. You can't get it, by the way. If I asked you to do it, you can't do it. Okay, you can't do it legally. Okay. So that's a big issue is you can't get a list of all the people. Let me give you another example where nobody could get it. And that is, let's suppose you worked for the Forest Service and you wanted to find the average height of pine trees in the Sierra Nevada wilderness, Sierra Nevada forest. And you wanted a sample of 283 trees. You want to randomly do it. Can you get a list of every tree? Right? Not going to happen, right? Not going to happen. There's probably like hundreds of millions of trees. I don't know how many, but a hell of a lot of trees in the Sierra Nevada forests. And there's no way in the world anyone could count them all. By the time you counted them all, you'd be dead and there'd be new trees up there because it would take centuries. So there's sometimes it just can't happen because you can't get them all. Does that make sense? Okay, so that's one issue. Another issue is, especially with surveying people, is not everyone will answer. Okay, finding those people sometimes hard, especially homeless people, by the way. Okay, good luck finding homeless. You can't get their address, right? So there's all kinds of issues with trying to get a random sample. Okay, so the next thing you do is you come up with, well, maybe we can find another method that will help prevent bias, not quite as good as random, but help prevent bias so that you at least have a scientific study and you can do what you can to prevent bias. So let me pop back into what we've got. Okay. So we talked about random sampling. So that the definition is every individual is just as likely as any other individual to get selected. Then there's stratified sampling, and stratified sampling is the most common means of sampling. And it Wait, there we go. There we go. It has a following step-by-step process. So first, step one. Step one is decide on the strata. So for example, you're going to look at this survey and you're going to say, well, we want to make sure that we don't have bias. We want to make sure that we have the important types of people represented in the study. So what kind of bias might happen if you don't do that? In other words, what kind of person do you want to make sure? And let me give you some of the examples that you often look at. Race is one of them. Sometimes, a certain race will feel one way and another race will feel another way. Income is another one. Rich people might think one way, they can pay someone to do the shoveling for them, for example. Whereas, people that are low income can't pay. So income is another one. Political affiliation is often used because Republicans think very differently than Democrats in lots of ways, for example. So race, income, age is another one. Young people have different feelings than older people often. So you decide on the strata that you want to do. For the Tahoe thing, one of the strata might be what town you live in. South Tahoe people might be very different than Incline Village people, different towns. If you don't know Tahoe, just those are different towns in the Tahoe area. So you decide on the strata and you decide what bias you want to prevent. Any questions on that idea? Okay, that's step one. Step two. Step two is you research the percent of each type. So for example, if you were doing race as the main strata that you're looking at, then you would go online, go to the Census Bureau or something like that, and say what percentage of Tahoe area people are Hispanic, what percentage of Tahoe area people are Caucasian, etc. And you do that research. Nowadays, that's usually not that hard. Okay, as long as your strata is reasonable like that. So that's step two. Step three. Oops, what happened? Step three. Oh, I know what happened. Always weird when Zoom is happening at the same time as your program is. It hides stuff. Step three is multiply the percents by the sample size to establish quotas. So what I said is our goal was 283 people that you were going to want to survey. And let's suppose we found out 40% of the Tahoe residents were Hispanic. Then we take 40% of 283 or 0.4 times 283, stick that in a calculator, and you get a number. And that's your quota. Quota means that you must survey that number of Hispanics. And you do the same with Caucasians and say it was, 43% Caucasian. I have no idea, by the way, so don't quote me on these numbers. Then you would multiply 0.43 times 283, and that would get, and you round in the nearest whole number. And that'll give you the quota for Caucasians. You do the same thing for Asians, you do the same thing for African Americans, etc. And that gives you your quotas. Okay, notice this doesn't take very long. Design the strata could take a little while because you have to think about it. Researching, usually that's quick. Usually that's online. In 5 minutes, you can usually find it. Multiplying the percents, that's quick calculator work. Not even 5 minutes, you can do that. Now comes a really long one. What's the really hard part? Conducting the survey. So ask. So conduct the survey. Ensuring the given quotas. So in this case, when you're doing stratified sampling, you have to ask two questions. The first question is, what is your race? And then the second question is, what was the biggest, what was it, trouble or something? Let me find it. What was the worst part of Deep December Storm? And what you do is you keep asking, ask and ask and ask lots of people. And let's suppose you get to the point and you're not there for everyone, but let's suppose you've already asked the right number, your quota for Hispanics. And the next person you ask said they're Hispanic for the first question. You say, thank you for your time, and you don't ask the second question because you already have established that quota and you don't go over the quota. Okay. So you keep asking until you get the right number of each of the quotas. For our class, we're only going to do a single strata. In the real world, you often do multiple stratas. So you'll do race, age, religion, and a whole bunch of other things, political affiliation, and you do all that stuff. This is elementary stats, so I can only go so far. So for your project, for example, if you do stratified sampling, one strata is enough. Okay, you don't have to pick 7 different types. So if you do race, that's good enough. Or if you do gender, that's fine too. But do one of them, not many. But in the real world, you do many. Any questions on stratified sampling? Again, it is the most common. It's the most common sampling technique of good research projects. The most common for bad is what we just saw, and I'll show you. I'll have a name for that too in a bit. Just to let you know, and this may surprise you. I've known about surveys for a very long time. One of my very first jobs was I was a person on the phone calling people up and conducting a survey. Okay, and I actually did that. And here's the thing, it was one of my first jobs, and I worked for a company called Carroll Davis Market Research Company. How old do you think I might have been? Just a guess. It's nothing to do with stats, just for fun. When I did it, I've been working a long time. I was 11. Nowadays that company would go to jail, but in those days things were different. And had nothing to do with me being a future statistics instructor or anything like that. I was just a kid, and I made minimum wage. So it's kind of funny. So I've been doing this forever. So I really understand what surveys are from when I was little. Kind of funny. Okay. The next kind of sampling that's really important is called cluster sampling. So let me give you the example of the pine trees again. Okay. If you did a random, let's say you did a random sample, like you're able to use satellite data, and you're able to pick, 283 trees throughout the Sierra Nevadas. What's the problem with that? Let's say it was 500 trees because that's a nicer number. Okay, so maybe 1,000. That's a big sample size. 1,000 is plenty big. Okay, 283 is big enough too, but you haven't learned that yet. There's a big problem. That is, if you use satellite data and you randomly pick 283 trees throughout the Sierra Nevadas, you'd have to go to them. And I love it. By the way, I love backpacking. You'd be backpacking for a year, which would be fun, but it's kind of expensive if you have to pay someone to do it. You can't do that. Does that make sense in the real world? So if the Forest Service wanted to sample, let's say 1,000 trees, they wouldn't use random sampling, even if they could, because it's too hard to get to the trees. Does that make sense? So they're going to use what's called cluster sampling. So what they might do is maybe take a satellite and make a picture of a map of the Sierra Nevada mountains, and then cut it by maybe 1 acre each. Make a grid in the Sierra Nevadas with each grid square would be 1 acre. And then what they would do is they would select maybe 10 different grids, okay, maybe 20 grids that each have 50 trees in them. Okay, or so, where the grids that are selected are representative of the Sierra Nevada mountains. So some would be higher elevation, some would be lower elevation, some would be in a meadow-ish area, some would be, different places, some would be east, some would be west, because those are different. And they would find representative, maybe, like I said, maybe 20 representative grids in the Sierra Nevadas that nicely represent the whole mountain range. Does that make sense? Then they would go backpack or travel to those 20 selected grids that you could do in a week or two. Do you see that? And then measure using, some measuring capability, all of the trees in each of the grids that are chosen. And that's called cluster sampling. So they've selected clusters. Okay, so let me write this down. So cluster sampling means that you divide the population into clusters. Okay, is diversifying the sample part of using different grids? Yeah, so you want to make that's good cluster sampling, is you want to make sure that you don't, like, say, pick all high elevation acres, because that's going to have some lower, if you know the Sierra as well, that'll have lower height trees. If you want to do, say, tree height, that would have too low height trees. So that's why you would want to make sure that you have representative acreage. Does that make sense? Okay, so that's the idea. Okay, so you divide the population into clusters that represent the population. Okay, and then sample every item, and that could be a people, by the way, too, in each cluster. Just to let you know, this is done a lot. Let's say you wanted to survey students. Okay, maybe students at Lake Tahoe Community College. Cluster sampling would be the way you do it. So what is a natural types of clusters? It's certainly not acreage, by the way. There's a natural cluster that's easy to grab and ask. Classrooms, okay? Better is classes than classrooms, by the way. Classroom, you'd have to sit there all day long in that classroom. That could get boring. And besides that, there's online classes too, and then classrooms get really weird. So what you would do is you would go to the schedule of classes at Lake Tahoe Community College, and you would pick a few online classes. You would pick a few morning classes. You would pick some evening classes. You would pick a daytime class. You would make sure you're picking some transfer classes. You'd pick some more CTE class, career technical education type classes. You might pick a few fun classes like kayaking, that type thing, and make sure that you're represented the courses that are offered at Lake Tahoe Community College. You go to those, say, 10 classes or whatever you picked, and then you survey every student in each of those 10 classes. And you have the professor do the surveying, because it's a social thing that if I surveyed you guys, you would answer the question more likely than some random survey person asking you. So that's done a lot. So that's how it's usually done. Any questions on that? Okay, you can also do clusters by time. So let's suppose you want to do a sample of your business, and let's say you own a restaurant, and you want to find out how much people spend. Then you might say, well, I'm going to look at a weekend, a Saturday evening time for 15 minutes of people who come in, and I'll look at a Tuesday lunchtime, and I'll look at some clusters of times and look at the receipts for all the people in those clusters. Does that make sense? So there's lots of different types of clusters that can be used. What's nice about it is it's logistically much easier than the others. Okay, and you can reduce some bias. It's not perfect, but it does pretty well. Okay, then there's systematic sampling. Systematic sampling, what that has done, especially in manufacturing. So I'm going to give you the example. I actually had a student that took my class and asked later on, much later, actually years later, I got an email from him. He had his own business and he made towels for hotels. He manufactured towels for hotels. And he wanted to show that his towels were better than the ones made in China. And for him, better means that if you wash them a bunch of times, they don't get ruined. Okay. So he asked me, well, how could he sample his towels? Okay. And you certainly can't sample them all because you can't wash them all 100 times and then try to sell them. That doesn't work. So he needed to do a sample. And what I suggested, and he did, was systematic sampling. So imagine it's a big towel manufacturing factory, and there's a big assembly line. So what I had him do is I don't remember, something like every 100th towel that came off the assembly line, then he had his worker grab, put it in the washer a bunch of times, and then sample it. So that's systematic sampling. And that means that you sample every, I'm gonna write nth. Doesn't always have to be 100th. It could be a 1,000th or whatever you're doing. Every nth item in the population. So he did that for towels. You can actually do that for students, actually. Okay, because what you can do is if it's the admissions and records, they can say survey every 50th student who registers for classes that quarter. And that would be systematic sampling. Any questions on systematic sampling? Okay, then there's convenience sampling. Convenience sampling is what we started with. And that was this one. When we had the Tahoe Tribune, just whatever's easiest, just grab whoever wants to answer your question and use it. So that's called convenience sampling. So that is collect data on whatever's easiest. Okay, the problem with convenience sampling, it is highly, highly prone to bias. Okay, because all kinds of things that can happen. So for example, if I wanted to find out the average height of my students that I've ever had, and let's suppose that, I knew I want to do that from the very first class I taught as an instructor. Could I have just grabbed my first class and found out what their average height is and said, that's good enough? Do you think that's biased? Okay, I love this example because you'll be in shock when I tell you. Their average height was 6'11". Okay, any guess? There's a big reason. No lies. Okay, it was actually a pre-calculus class. But what it was, let me tell you, is that I was at UCLA and I taught the basketball class. I had a 7'7" person. Yeah, I had the basketball team and they all took my class. It was a special class. So that would be total convenience sampling. It'd be totally bad. Okay. All right. So that would be as biased as it gets. So I could let you know that bad things can happen if you do convenience sampling. Any questions on these different sampling techniques? Okay, I want to give you a heads up. We're going to talk about this next week, but your project 1, which hopefully you're all already getting partners for. Pretty much the requirement is stratified or cluster. You can technically do random, except what I mentioned, you can't do random because it's of people and random is way too hard. What's the difference in cluster and stratified? So stratified sampling is you decide on a strata, like race, And then you ensure that you have exactly the same percentages of race in your sample as there is in the population. Cluster sampling means you find groups. You kind of divide the population into groups and then grab some of the groups from the population, trying to make sure that the groups represent the population nicely. Do you see the difference? So they are different. They're definitely different. And they both do what they can to address issues, bias issues, but they're not perfect. Okay, perfection's pretty much for people, for surveys of people, is always impossible. Okay, perfection's not going to happen. One of the big issues that you're going to see in almost all human sampling is what's called voluntary response bias. Hopefully, just from those words, you know what that means. Okay, let me ask you, put a yes or no. So the answer is, the question is, those of you who have received a call, a phone call from a survey, have you ever not answered their survey? So yes, I've not answered their survey. No, I've always answered. Okay. So notice all of you are saying yes. And by the way, it's always yes. You can see those voluntary response bias because you can't get everyone to answer your survey. And let me give you a great example of voluntary response bias that happened 5.5 years ago. What was a big survey that happened 5.5 years ago? I know it's a while ago. All right. No, not census. Census happened 2 years ago. Yeah, it was, who do you want to vote for, Trump or Clinton? Okay, you have to think back, and that's what was going on. And all of the surveys said Clinton was going to win the election. I don't know if you remember that. And then hopefully you've been in America long enough to, or looked at America long enough to know that Trump was our president. Okay. And by the way, I'm never going to tell you who you're supposed to like or not, but I will tell you the statistics, they got it wrong. And that was definitely voluntary response bias, because people who tended to vote for Trump were much more likely to hang up when they got a phone call. Okay, there's no question about it. So that was a statistical disaster. Okay, and a statistical disaster means they got it wrong. Okay, you might love Trump, you might hate Trump, that doesn't matter. But statistically, they got it wrong. That was not good. Any questions on kind of voluntary response bias? Okay, again, I can only do so many. We've done a lot of stuff already, and we need to move on to chapter 2. So chapter 2 is all about statistics, which is the name of this class. So let me tell you statistics. A statistic is a number that is calculated from the sample data. So I have some of them written here: mean, median, standard deviation, Q1, Q3, IQR, Z-score. I'll get to what all those means in a bit. There's others that you know, like range. Do y'all know what range is? High minus low. That's the range. So the range is the high minus low. So there's others too. But these are the main ones. And what I want to do is I'm going to do a few things. One, I'm going to show you 2 ways of doing statistics. You're not responsible for calculating statistics by hand. It's pretty brutal, by the way. When I first taught this class, I had to make students do that. And you know why? Because it was ancient times. Okay, the internet didn't exist, and fancy calculators didn't exist. So we had to by hand. It was brutal. We don't do that anymore. Now you can let me do all the work. So this is one of the pieces I did the work for. This is what you're going to be using for your project, by the way, which is a spreadsheet program I created. It's called Statistics by Larry Green. And the first thing you do is you're going to highlight whatever the numbers are. Actually, the first thing you do is you can go to File, make a copy, give it a name, and hit OK. And that way you can enter your data. This is a Google Sheets. So if you don't do, if I let everyone edit it, that means you're all fighting each other to put your numbers in. And if you ever use Google Docs and stuff, you'd be changing each other's stuff. So you have to have your own copy, and that's how you have your own copy. Then you erase what was in there. You find this link on the syllabus. So if you go to the syllabus, I believe I have it in here somewhere. Calculators, Google Sheets statistics program. And that's where it is. So if I click on that, it goes to where we were. And there it is. Okay, so I'm gonna do a survey. Just for fun, let me ask you, is there anything you're interested in? It needs to be quantitative. Because otherwise you can't do very interesting, a whole lot of stats. Anything you want interested about each other? Okay, how many people have dogs? That's a yes, no question. Do you have a dog? Do you see that? So be careful about how many people, because really, do you have a dog? Who has a small dog? That's still not a number. It has to be a question that has a number answer. Think about the survey question, what you're going to ask that person, and then out of that mouth needs to come a number. Otherwise, it's not quantitative. Okay, how old are you? I'm going to go for that one. Okay, how many pets could work, but you're not going to get a big range of numbers with that. You can get a lot of zeros, ones, and twos. Okay, unless you have a fish tank. But I don't know if you call those pets. I don't pet my fish. I don't have fish, but I did once. So I'm going to go for age. So, and I want to tell you about the rule of this class. First thing, if you put it in the chat box, it's not seeable by the YouTube, so you don't have to worry about that. I want you to put in an answer to the question. If you feel comfortable about it, give me the answer, the truth. If you don't feel comfortable about it, then you can make something up, you could lie, but give me something reasonable. Do not tell me you're 900 million years old. So, and don't kill me your 1-year-old either, because we can't have a 1-year-old student. So give me your age. Most people feel comfortable, but if you're not, you could lie, and that's okay, but just make it reasonable. Okay. And there's a lot of you, so we'll put numbers in. So it's really, I tried to make this as easy as possible. So I'm going to start putting numbers in. 26. So I click that, I type 26, I hit enter, then 20, enter, then 38, 17, let's see, 38, 17, 20. $29, $37, $27. And 38. And I might have missed some, but again, what I'm showing you is how to do it. I'm not being very careful because careful is not important. It's just an example. All right, any questions on how I just put in the numbers? All right, so we did that. And now all you have to do with this, and this is why I like using computers instead of calculators, is all you have to do is move your eyeballs. That's pretty easy, isn't it? I'm gonna move my eyeball over here. And the minimum number was 17. Okay, that is a statistic, by the way. That's a number calculated from the data. From those numbers, I was able to calculate the number 17 by looking at the smallest number. So hopefully I don't have to explain the word minimum. Hopefully you know what that means. The mean. What's the nice, simple, easy way I mentioned a little earlier for the mean that other people use? And don't say like angry bad person. That's a different kind of mean. Middle, not quite. Middle something else, actually. Remember? Average. There we go. Yeah, we got an average. Yeah. So that's the average. And the math is you add them up and divide by the total, in this case 9. And so the mean was 28. So the average student's age is 28 years old. The sample, I'm going to go for standard deviation. Variance, we're not going to do much in this class with. So just a note, don't try to interpret the variance. There's all kinds of issues with it. The units of variance for here would be square years, and it's just not very interesting. So we're going to look at the sample standard deviation. That is important. So the standard deviation is how spread out the data is. So the standard deviation, the sample standard deviation is 8.185, et cetera, about 8.2 years. So that means that if we start at the mean and we add a couple standard deviations from the mean and we subtract a couple, that's going to get most of the people that answered the question. Okay. So that's really important. Let me give you a actually very practical, depressing use of standard deviation. All right. So when you look at what is expected of how much precipitation California is going to get now that we have climate change, what do you think? Do you think we're going to have less, or do you think we're going to have more on average? Okay, that's what I thought you'd all say. It turns out that we're expected to have a little bit more. We're expected to have a little bit more on average precipitation. Does that mean we don't have to worry about droughts anymore because we're going to have a little bit more average precip? Okay, why not? Location, California, actually, that's not too much of a problem. Let me tell you the problem, because the standard deviation is supposed to go up a lot. So now let's talk about what that means to say the standard deviation is going to be high. Okay, so what that means is that most years are not going to be anywhere close to the average amount of rainfall. So we're going to have years, okay, like last month in December, where we just got nailed, right? Okay, I'm saying precip because in Tahoe we got snow, and we just got nailed. Okay, on the other hand, we're going to have years where we get almost nothing. Do you see that? And they tend to come in waves. So because we're going to have a high standard deviation for the precip in California, that means we're going to have periods at which we're going to have really bad droughts. And we're going to have periods that we're going to have really bad floods. It goes both ways. Do you see? It's both sides when you have a high standard deviation. Even if the average is a little better, we're going to have more droughts. That sounds weird, but it turns out that's what's going to happen. Okay. So I told you it's depressing. Sorry. But I like to give realistic stuff, and this is realistic, and I have done my research on this. Okay. I'm not a meteorologist, by the way, but I have read reports from meteorologists, peer-reviewed journals where they're very trustworthy. And this is what the predictions are. Okay. And they're based on pretty good science. Is higher standard deviation, slightly higher mean. Any questions on how important the standard deviation is? Okay, let me give you another example. Let's suppose I told you that my goal in this class is I want just about everyone to pass the class. Sound like a good goal? I told you that the average percent for the course was 74%. Have I reached my goal? If I want everyone to pass the class, or most people to pass the class, and I said the average percent was 74%. Okay, it's a trick question. The answer is you can't tell me because I haven't given you the other piece of information you need, which is the standard deviation. So if I told you the average score in the class was 74%, and I said the standard deviation was 1%, then you would say, yes, I reached my goal. Because 70%, which is what you need to pass, is 4 standard deviations below the mean. Do you see that? And by the way, 4 standard deviations is almost impossible. So pretty much everyone passes the class. If I told you the average was 74% and the standard deviation was 20%, then I might have like a huge group of you not passing. Do you see that? It's like all A's and all F's and D's. Do you see how that works? And I didn't reach my goal because a lot of F's and D's. So you need more information than the average or the mean to understand what's going on. And the standard deviation is the biggie. And that's something you pretty much can't pass this class if you don't know what the standard deviation is. Okay, I'm not going to get into the details of the mathematics behind it. It's in the book. You can look at the math. I'll be happy to chat with you after the webinar is over, but you might cry when I tell you because it's kind of, it's really messy math. But you should know how to use a computer to do it. And there it is. Okay, so we can say the standard deviation is around 8. So that means that kind of on average, people are 8 years different from the average, which is 28 years old. So kind of the majority of people are between 20 and 36 years old. Do you see that? 28 minus 8 is 20. 28 plus 8 is 36. Any questions on that? Okay, the median. That's when you learned when you're in middle school, probably. Anyone know what the median is? And I mentioned it a while back, like towards the beginning of the class. Yeah, that one's the middle. Okay, the middle or the average of the two middles if there's an even number. In this case, there's an odd number of people that answered. So that's the average. It's not the average, it's the middle. So in this case, the middle, okay, the median is 27. Okay, where do you hear median cited in the real world? It's actually cited in one place. They almost never say average. Median driving. I'm not sure what driving is. Is that speed, age? I don't know what number that represents, but that's not the one I'm thinking of. There's one that you hear a lot. Okay, median home price. Have you heard that median home prices before? When they talk about, your town and what the price of houses are for the town, they usually use the median instead of the mean. Let me explain why. Let's suppose you want to get a feel for the community of South Lake Tahoe. Okay, the problem is there's that like really serious $25 million house that sits on a lake. Okay, by the way, that's not mine. My house is pretty close to the median, by the way, because I work for the government. I have a median salary. So you have that super house, and that house, if you take the average, that is going to shoot the average way up. And what you're going to end up with is an average that actually there's like maybe no houses that are anywhere near the average, because you're going to have most of the houses are, in the maybe 500, maybe nowadays, maybe $650,000 range. Didn't used to be that. Like the last couple of years, it went way up. And on the other hand, there's a few that are in the 20 million range. So if you say 650,000, that's the median, then that's going to give you a general idea of what our community's like. Whereas if you take the average, that might be $1 million. And that's not a typical house. That's kind of a high-end house. Do you see that? On the other hand, who might be interested in the average house price? And it's not the person that wants to look at the typical house. And the sellers, sellers just want to know your house price. So the hint is, I was one of them. Not wealthy people. Nah, wealthy people want to see that $20 million one. I was one of them. That's a hint. No, not buyers. Now you don't know my history, so that didn't help you to give me my hint. No, let me tell you, politicians. Okay, I'm a stats person too, but politicians. I haven't told you I was a politician. I was an elected official for 9 years. I won 2 elections. Um, I was on the school board, and we had a bond, and we wanted to see how much things are going to cost people for our bond measure for improving the Lake Tahoe Unified School District, improving the high schools. If you guys went to the high school up here, then you saw we had there's some amazing facilities there. That came from that bond issue. And the way it works is that $24 million house, they pay a whole lot more taxes than my house. So those politicians need to know about the average home price, because that is going to tell them how much money is going to come in if they say we're going to tax by 1% of the house price. Do you see how that works? Whereas the median is not very useful at all, because it doesn't tell you how much revenue you're going to get, whereas the mean does. Any questions on that example? Okay. Maximum, I hope I don't need to explain what a maximum is. That's the highest number. I want to jump to Q1, kind of in order that's better than Q3. I tried to switch these and it just messed things up. So sorry about that. I did my best on the spreadsheet. I couldn't switch these around because it messed everything up. So Q1 is really the next one, and that's called the first quartile. And when that basically means, and especially when you have a large sample, by the way, is that about 25% of the data is at or below that first quartile. So quartile is 25%, right? Quarter is 25 cents. So that means that 25% or a quarter of the students are 20 years old or younger. Q3, any guess on what that might be? Since Q1 is the first quartile? It's not a trick question, by the way. Yeah, that's the 75% of the third quartile. So 75% approximately are at or below the age of 37 years old. I want to let you know, I'm going to say this kind of quickly. I'll tell you, of all statistics issues, this is the one that drives me the most crazy. And that is, there is no agreed upon formula for quartiles. Doesn't that suck? If you use a TI-84 calculator, you get a different answer than if you use Excel or Google, which is the same as Excel, because there isn't an agreed upon formula. It drives me crazy. So I'm not going to ever ask you to do the computation of a quartile because it's complicated. So it's just horrible. So sorry about that, but I do want you to understand the idea of the quartile. When you have a large sample size, then it's good enough. And that is about 25% is at or below the first quartile, 75% at below the second quartile. Sometimes you'll call them percentiles. You'll call it the 25th percentile is the first quartile, and the 75th percentile is the third quartile. Got it? Let me give you an example of percentiles, because those are important. Let's suppose you are a nurse, because I know we have some nursing students here, or pre-nursing students. And you do what my brother does, by the way. My brother, by the way, is a birther. He delivers babies for a living. Kind of cool. Let's say he delivers a baby and you're the nurse with him. And the baby is in the first percentile. Is there any issues? What do you think? So the baby's in the first percentile in weight. Like I said, it's very important for nursing because you got to understand that. It's very tiny. That baby's going to ICU. That baby's in trouble. First percentile is not good if you're, and by the way, if you don't know any medicine, you can trust me on this. I've talked to my brother. If they're in the first percentile in weight, there's all kinds of possible problems. Yeah, it is a preemie big time. So you usually look at the percentile because that will tell you how healthy that baby might be. What if you do a you do a you know, a scan of the baby in the womb, and you find out that baby is in the 99th percentile, and you're the nurse? What are you going to tell that patient, that mother? Yeah, it's big, probably a C-section. Okay, we're probably gonna have to do a C-section because that baby's in the 99th percentile. It's too big, and there's going to be a big risk when that baby's born, not to the baby, but to the mother, because it's going to tear apart the womb. I won't get into the details, but you can imagine it causes very possible issues. Big babies tend not to be unhealthy. Little babies tend to be unhealthy. So just to give you an idea, percentiles are really important. And Q1 and Q3 are the 25th and the 75th percentiles. Any questions on that? Okay. Those are the main statistics. I want to give you one more statistic that is important. That's called the Z-score. I'm going to pop this in here. I think I might even put it in here. So the Z-score has a formula. There aren't a whole lot of math formulas you have to have in this class, but this is an important formula. And that is Z is equal to X minus mu over sigma. Okay. And the funny thing is, in the old days, 2 years ago, most of you didn't know any Greek letters. Why does almost everyone know, kind of a sad way, a lot of Greek letters? Most of you probably know what Omicron is, for example. Yeah, it's what they call it. It's what they're labeling COVID. But math got to Greek letters first, and mathematicians tend to use Greek letters. So do I have it here? No, I don't have it here. So I want to let you know that mu, right here, this is the letter, Greek letter for mu. So just remember your cat. My cat just jumped way over there. When I walk over there, she's gonna ask. She wants food, and she's gonna go mew mew. So just remember that's the Greek letter for mu. Okay, and the first sound of that is m, which is the first sound of mean. So if it's a Greek letter, that usually means it's population. So mu is the population mean, whereas the sample mean, we put an X and throw a bar on top of it. This letter here on the bottom is a Greek letter also, and that is the letter sigma. It's a Greek letter, sigma, that has that letter S as the first letter, kind of in sigma. And what statistic did I spend a lot of time talking about that has that Greek letter, that has that sound, first letter S? Told you it was like the most important of all. Standard deviation. Yeah. So the population standard deviation is sigma, whereas the population mean is mu. And by the way, the sample standard deviation is really easy. We just use S. So that's nice and easy. So Z is X minus mu over sigma. And we often approximate the population mean and the population standard deviation using the sample mean and sample standard deviation, if you can't get it. And so X minus mu over sigma is called the Z-score. And the Z-score tells you how many standard deviations above the mean the value is. Okay, and by the way, if the Z-score is negative, if you're -2 above the mean, then hopefully you can figure out that means you're below the mean, right? Okay, you're 2 below. Our definition that we're using in this class, by the way, is that we're going to call something an outlier if the Z-score in absolute value is greater than 2. So it has to either be bigger than 2 or less than -2. If the Z-score is greater than 3 in absolute value, it's an extreme outlier. Okay, typically for, a lot of situations, the outliers represent around 5% of the data. The extreme outliers represent like 0.3%. So it's extreme, very unusual. So for example, if we look at our example that we just did, let's say we wanted the z-score for our 38-year-old, one of the 38-year-olds. Then you do a little arithmetic. You take 38 minus, and I'm going to use the sample standard deviation, 8, I'm just going to go 8.2. Minus the mean, sample mean. I'm going to use a sample because I don't have the population mean. So I'm going to take 38 minus 28, and then I'm going to divide by the sample standard deviation. Let me put that in the chat. And divide by the sample standard deviation, which is 8.2. Okay, normally use population if you can. If you can't, use a sample to approximate it. And that is our z-score. Okay, I actually created a find the z-score using this. See where it says X, change this? So let's change it. Let's do 38. And our z-score is 1.22. Is that an outlier? So is the oldest person in the group an outlier? No. No, remember, outliers have to be bigger than 2 or less than -2. And 1.22 is not bigger than 2. Any questions on that? How about me? Would I be an outlier? I'm 55 years old. Would I be an outlier? Yes. Would I be an extreme outlier? Yeah. Okay. By the way, I went to college a long time ago. When I went to college, I was not an outlier. I was normal. But I'm not in college anymore. I'm not a student. So I would be an extreme outlier. Does that make sense if I went back to college, for example? Any questions on outliers and extreme outliers? Any questions? Does this make sense? Okay, so you're going to be asked to do this kind of stuff for your project. You're going to have to analyze your data and talk about outliers, talk about extreme outliers and explain it. Okay, I'm going to talk about that next week too. Okay, just a note, there's something called Chebyshev's theorem. Okay, there's something called Chebyshev's theorem, and that says that if you have a bell curve shaped distribution, we're going to call it normal distribution. Now I'm going to look at this. Does this look kind of bell curve-ish, a normal shape or not? No. In fact, this is what we call skewed left. Skewed left means we have our high points over here, and the left-hand side is where the tail is. Do you see that? It's not symmetric. It's not the same left and right. It's different. Okay, this is skewed left. This is not anywhere close to normal curve. So I'm not able to use what's called Chebyshev's theorem. If I was, then Chebyshev's theorem says about 95% of the data lies within 2 standard deviations of the mean. Okay, and about 99.7% lies within 3. So almost all of it. That's Chebyshev's theorem. It's all in the book, so I'm not writing it all out because it takes too long to write everything out. So this is a histogram, and a histogram is a bar chart for quantitative data where you have separated your x-axis in equal widths. Do you see that? Okay, I'm going to let you know there's some other important types of looking at data with charts. And I'm going to warn you that if you do what I'm about to do, it may not let you. For some reason, Google hates me now. I don't know why. By the way, it's going to ask you, are you sure you want to trust this site? It might give you a virus. I promise you, I will not give you a virus with my program. If I go to box plot, I'll do that one first. Then that's going to give another chart, another way of looking at the data. And what this does is it does what's called the 5-point summary. These are kind of the key five, some key 5 numbers. So let you know this highest bar. Any guess what that might mean? Which is 38, by the way. Yeah, that's the highest or the maximum. Okay, the lowest bar, I'm hoping you can all guess that one too. 17, by the way. That's the minimum. Okay. Okay, any questions on that? Okay. By the way, my daughter was a minimum when she took stats. Any guess? No, she wasn't 8. You can't take a college class at 8. No, but she was 15. Yeah, she's my daughter. Okay, 27, right here. This kind of the middle line. Any guess on what that one is? That's the median. It's the middle, the median. Okay, then we have 20. What do you think 20 is? Yeah, that's Q1. And then we have 37. What's that? That's Q3. So this is what's called the box plot, which gives what's called the 5-point summary, because there's 5 lines. In particular, between 20 and 37, the box itself. That's kind of the main point of the box plot, is the box. That is called the interquartile range. And that's a long word, interquartile range. And that is the middle 50%, because it's in between the 25th percentile and the 75th percentile. Do you see that's the middle half? So it says the middle half, kind of like the typical student, is between 20 years old and 37 years old. Any questions on that? And everyone older or younger, they're kind of not typical. Do you see that? They're not in that middle group. So if you want, like say in business, sometimes you want to advertise to your typical group of customers, like maybe by age or something. So then you would advertise to people between 20 years old and 37 years old. Do you see that? If you want to think of it that way. So often, you know, if you want to focus on that middle group, okay, that's how you do it. If I want to teach to the middle, then I'm going to see what my interquartile range is for the grades, say on the first exam, and I figure, okay, that's who I've got. Okay, that's my middle group in terms of, you know, how they're doing in the class. Any questions on the reading a box plot? One issue with a box plot is, let's say you presented this in a presentation to just say a group of community members, no one special, and you showed this picture. What's the problem with it? Any suggestions? Why is it not a good idea to show to just a group of just community members that are nothing special about them? Exactly. They have no idea what it is. So box plots don't work for people who don't know statistics. Box plots are great for people who do know statistics, but they don't work for people who don't know statistics. Any questions on that? Whereas histograms, most people understand histograms. Most people have seen bar charts and people understand it. Box plots are now taught in high school. They didn't used to be. So if you're the 38-year-old, you didn't have it, probably. But if you're the 21-year-old, you did in high school. Or if you didn't, then your teacher was not doing the teacher's job because they're supposed to do it now. Any questions on the box plot? Okay, I'm going to drop the box plot. I want to let you know, again, your computer may not let you do it. So what I did is I have some links to some boxplot creators that computers aren't afraid of. So sorry if mine makes computers afraid. I didn't mean to. All right, so then there's another one. Let me go to stats again. And I'm going to stem and leaf. And it's called the stem and leaf diagram. This is really nice when you have the following. When you have, say, 2-digit numbers, or only 2 digits you care about, then it shows you all the data. Whereas the histogram and the box plot, you don't know the individual values. So I know, for example, from looking at this, that there were 2 students who were 20 years old, exactly 20 years old. I know there was 1 student who was 27 years old. You don't get that from the histogram, and you don't get that from the box plot. The way you read this is why I knew there were 2 students who were 20 years old is this 2 is a tens digit, and there were 2 zeros here. So there was a 20, that's 20, and another person who was 20. I knew there was 1 person who was 27 years old because there was a 27. You see how that works? All right. So that's what a stem and leaf diagram is. Okay. If you're going to do hundreds place, which you can, then it's going to round to the nearest 10 and show 100 tens and round. Box plots have the same issue. I mean, sorry, stem and leaf has the same issue that box plots have, is that general people don't understand them. That's a problem. Another big problem is, let's say you had 1 million in your sample. Box plots, stem and leaf does not work. How come? Why would this be a disaster if you had a sample size of 1 million? Yeah, you'd have to have 1 million numbers here. Good luck putting that on a computer page or something. So it won't work. You can't do box plots when you have a giant sample size. It works for modest sample sizes. Okay, 100 is fine. You can probably make that happen. 1 million isn't okay. Any questions on these different plots? There's a lot of other plots. Some you've seen, like pie charts, and others. I'm going to let you read about those. I can't do every detail in this class. Here's what I can do. How do you get the histogram calculator? Oh, that's automatic in here. It's just there. I didn't have to do anything. Histogram is really easy with Google. Google likes histograms. Stem and leaf, I literally had to code it. I won't bother you, but there's a lot of lines of codes that I'm a coder. So trust me on that. But what do I need to do that I haven't done yet? What do I have to tell you? Yeah, secret word. Okay, and the secret word for this lecture is stratified, because that was, I told you, that the most important method of sampling that's used in scientific ways of doing it. Let me make it bigger because it might look small. How's that? So the secret word is stratified. Stratified sampling is a main sampling technique. So don't forget, for the secret word quiz, I did put these here, so I figured I'd show you. So let me show you symbols. Yeah, lowercase. Yeah, don't put capitals. X with a bar on top of it, which we read, by the way, X bar, is the sample mean. This Greek letter, mu, is a population mean. This S is a sample standard deviation. This sigma is the population standard deviation. The way you can remember mu, here you go. That's how you remember mu. Although my cat's kind of a quiet cat. I can't get her to meow unless I have food that I'm teasing her with. So that's a population mean is my cat's language. So those are, again, very important to have these down. And if you're using, say, Google Docs, which we're using now, and you want to do mu, it's a little bit of a pain, but it can be done. That you can go into insert, go equation, and then there's Greek letters. And mu is this one, and it makes mu happen. So that's how you do it with Google Docs. With Microsoft Word, you can insert, you can do font, Greek font, and that will do with Microsoft Word for do a mu. And by the way, Sigma is the same idea. You click on the Sigma. Okay, so just let you know, you know, for your projects, you can do this. You can put these in, they make them bigger. Okay, again, I can't go over every single detail. I went over a lot of stuff today, didn't I? Okay, went over a lot of stuff. Next week, I don't have as much to do. I have a lot fewer items to talk about next week. Should you smile or frown? What do you think? Yeah, I want to give you a warning about next week. Next week's hard. Next week's probability, and a lot of people have trouble with it. This week, if you read the book and you watch the lecture, most of it's not very confusing. Next week, a lot of people have it's a hard week, and that's probability. It's very important, actually, but it is a hard week. Just a little warning about next week. So we've gone an hour and 32 minutes. It's a kind of an hour and a half is kind of around what I like to do for the webinars. So I'm pretty close. But what I'm going to do is I'm going to stop share. And I am going to stop the recording.